At conceptual design, we decide about column layouts, we decide about framing, we decide about grids, we decide about initial sizing of elements. At that stage, it is absolutely crucial to come up with initial analysis, and that intuition will help you that how initial analysis will look like. And secondly, I will say to validate final computer outputs at detailed design stage.
So the next question, how does intuition play an impact in structural analysis?
This is really, really thoughtful question. And when I thought about it, I had my point of view as well. But David Braun, in his book, Understanding Structural Behavior and Structural Analysis, he talks about two things and which are really very important, and I totally agree with that. One is at conceptual design. At conceptual design, we decide about column layouts, we decide about framing, we decide about grids, we decide about initial sizing of elements. For example, if somebody asks you, how would you size a beam, a secondary beam, a beam with uniformly distributed load? You say that I would decide about depth span over 20. This gives us really good starting point. At that stage, it is absolutely crucial to come up with initial analysis, and that intuition will help you that how initial analysis will look like. And secondly, I will say to validate final computer outputs at detailed design stage. So when computer analysis has been carried out, then to validate it, you need some simple calculations. I was attending one event by the Institution of Structural Engineers president, past president, and he said a really very important thing a couple of years ago. And that really struck with me. He said, a moment in any structure, it can't be worse than WL square over 8, which is a simply supported beam, which is a moment for simply supported beam. And second, it can't be better than WL square over 12, which is moment at the fixed end. So if we can, it's obviously you would say real structures are more complicated than simple things. But yes, as a first guess, we can check things like that. And this is what I believe in, that we should be learning how structures will behave in real life and what will be possible failures, what will be possible deflected shapes. And that will really guide us to a very useful direction. I would like to share a few quick examples on how to draw a bending moment diagram. In this question, we have to identify bending moment diagram for this load case. Note that loading values are not given. When we have to draw the bending moment diagram, and here bending is on tension side. It means by tension side, we mean that it's like this. So when it's bending like this, tension is drawn here. In the UK, we draw it, I think in India as well, we draw it like this. In North America, they draw this sagging bending moment like this. Take a screenshot of this question, and I'm going to give you some options. When the screenshot is taken, I will go to the options. See that UDL is applied in the middle, and we have a point load at the end. It's a simply supported beam, but with overhang. There are 4 options to choose from. Option A, you can see we have bending at the end, and then option B, option C, and option D. What option do you think is correct? It's a very simple question. And I will tell you a 3-step process to work out bending moment diagram. So think about it. use your intuition and tell me which option is correct. A, B, C, or D.
We have started getting the response.
Okay, right.
The answer is given as a B by number of participants.
All right, excellent. It's a very simple one. Let's go through the process. First is we have to identify points of certainty to draw deflected shape. So where deflected shape will certainly pass through. So these are the points where deflected shape will pass through. Then we draw deflected shape in second step, passing through these points. So this is how we draw deflected shape. You can see at the right end, we have roller, so nothing is happening. So moment should not be over there. And at left side, certainly we will have moment. This deflected shape will tell us really very important thing. It will tell us the direction of reactions. So direction of reactions, both reactions are upwards. And now we remove the direction. We simply plot, because direction of reaction at left support is upwards here. It means the diagram should go upwards. And then we have downward UDL. The diagram, you can see it is a curved one. And then it goes up over here. So that's how then everything disappears. Then you can shade it to make it really look fancy, beautiful, because we like amazing aesthetic things. And all of you got it right. So correct answer is option B. Let me move to the next one. And here we have, in this question, we have to identify bending moment diagram for this load case. And ignore self-weight here, all right? Self-weight is ignored. How do we draw bending moment diagram for this one? There are 3 steps. Draw deflected shape, determine direction of reactions, and then that direction of reactions, it will really tell you where the diagram is going. Take a screenshot, and I'm going to show you few options that will tell you which option is correct. You will tell me actually which option is correct. Now here are options. Option A, option B, option C, option D. Think really very carefully about direction of reactions and how you would draw its deflected shape. Because there's a lot of common misconception about deflected shapes and about sagging and hogging moments. What do you think? Which option is correct? Is applied, a point load is applied. Is it option A, point load is applied over here? B, are we getting any responses?
Responses have started coming. One response is option D. One response is option A. Other response option D. Other response option A. Option D. Option B. Option D. Option B. Okay, option C has also come. Option C. Okay, option A, option C. Option A, option C.
Excellent, excellent. So you saw that just a simple problem. And don't worry if you get it right. 3 months ago, I got them right as well. I got them wrong as well. So don't worry if you get them wrong. So it's all right. It's not end of the world. We learn from each other. All right. I have so many questions. Actually, I have 100 questions like this. But due to shortage of time, we will cover just 2 or 3. All right. So let's go to. So first step is identifying points of certainty, which means that at these points, deflected shape will definitely pass. And then we draw deflected form. Now here, if you read this left middle point, it says deflected shape in direction of reactions. It says remove a support, a reaction that brings structure back to its original position, gives you the direction. All right. So here loading is applied at this point. All right. So which support should I be removing? I should be removing this support. So when you apply load over here, the deflected shape will probably go like this, isn't it? If you consider this support, fixed support at left to be removed. And what it will tell you is that because load is applied downwards, so reaction here should be upwards. And the reaction at fixed support, however, it should be a downward reaction because the load that will bring this deflected shape downward, downwards will be downwards, isn't it? So deflected shape is like this. Reactions are up over here and down at this point. And now we're ready to plot. And this is the moment reaction. This is horizontal reaction. So when we have these, when reactions are clear, then we are in a position to draw bending moment diagram. How do we draw it? We start from here, load is coming down. Beyond this point, beyond roller, we've got nothing. So it will not be anything over here. And then because of upward reaction here, because of continuity, it goes up. And then have a look at reaction at fixed support. Is it up or is it down? Of course it is down, downwards. That means that the diagram will go downwards as well. Okay? Then just rub off everything. Then hatch or shed this structure to make it look really amazing, beautiful, and aesthetic. and this is our answer. So the correct option is option D.